All right, so section 9.2, single step inequality. So it's not much different than single step equations that you've learned in grade 7, 8, and 9. We're going to go through some exemplars, and in talking about the exemplars, you'll probably understand what we're doing here. In question A, we have what number, when you take away 1.6 from it, the result of that expression, the value of that expression, will be less than or equal to negative 5.6. So if you stop to think about it for just a second, there are infinite values that x can be that will make it true that when you substitute a number into x, that value can be less than or equal to negative 5.6. But there are not all of the values will work. So what we want to do here is, if we think about it, if we treat it like we would an algebra question, what would we do to both sides if, instead of an inequality sign, this was an equal sign? Everybody knows what we would do, correct? What would we do? That's right. We would add 1.6 to both sides, correct? To solve it. But if we go back to the inequality sign, the exact same thing is going to happen. I'm still going to add 1.6 to both sides. And my solution will be any value of x that is less than or equal to 4 that I substitute here in this expression, x minus 1.6, any value of negative 4 or less will maintain this side being less than or equal to this side. So therefore, if I think about the numbers, any number less than or equal to 4, negative 4 would work, negative 5 would work, negative 6 would work, all the way to negative infinity, right, from there. And if we wanted to verify our answer, I could take any of those numbers. I'm going to choose negative 6, just because I can. And if I put negative 6 in here, negative 6 take away 1.6 is negative 7.6. And negative 7.6 is a value that is less than or equal to negative 5.6. So that's one of the values that we could use. So there's infinite values, but any value less than or equal to negative 4, as demonstrated by this set of numbers here, will work. In the second example, we have negative 10 is greater than 4x, or like I told you before, read from the sign that has a variable, and you can read backwards. So 4 times a number is less than negative 10. There are infinite values x can be, but we have to isolate for what set is that. Oh, I should have actually graphed that last one. I will do it again. So again, I'm going to divide both sides by 4. And any value less than negative 2.5 will satisfy the inequality for this one. So therefore, if I was to do my set of numbers, any number less than 2.5, so 2.6, then 2.638, negative 2.8, negative 3, continuing down that line or a spectrum of numbers will still work. All of those numbers are valid numbers. If I wanted to graph it, 2.5, so I would use the open boundary point because negative 2.5 is not included in those set of numbers because it has to be less than negative 2.5. And using our number line arrow, we could say that any of those numbers on that red line can be substituted in here for x to satisfy the inequality. Negative 10 is greater than 4x. And our last one, we have what number divided by negative 8 is greater than 3, or what numbers, I should say, can be divided by negative 8 to give you a value that is greater than a positive 3. So here we're going to say, I'm going to multiply both sides by negative 8, correct? This is where it gets tricky. X can be greater than negative 24. So then I take my set of numbers. Give me a number that's greater than negative 24. Has to be greater than. How about negative 23? Negative 1, 0, positive 6. Those are all numbers that are greater than negative 24 and should work. So then we go over here And I'm going to choose the number. I'm going to go, is negative 8 greater? Is negative 8 greater than negative 24? Yes. So I'm going to choose to go back into my inequality and substitute negative 8 for x. Did it work? It didn't work, did it? Because negative 8 divided by negative 8 is 1, and 1 is not greater than 3. But if I go back here and check what I did here, go back in time, it looks like I did everything right. I multiplied both sides by negative 8. I got x is greater than negative 24. So here we go. Here's the caveat note. And this needs to go in your notes. When solving inequalities, if you multiply or divide both sides, by a negative value, I always spell negative wrong. Is negative spelled right? I've only spelled it like literally 1,000 times in my life, and I never know if I spelled it right. When solving inequality, if you multiply or divide both sides by a negative value, you must triple underline. I'm going to, for x, that. It's like I'm yelling at you. You must flip the inequality sign. Okay, you must flip the inequality sign. So because right here, oh sorry, because I multiplied both sides by negative 8, the rule says in order to actually make that inequality actually work, you have to flip your sign over, and then every value will be correct. So here, if that's true, then any value less than negative 24, so negative 25, negative 29, I'm going to choose negative 32, etc., etc. Those are all values that are less than negative 24. And if I then go back in and substitute negative 32 here, then I get negative 32 divided by negative 8 should be greater than 3. And negative 32 divided by negative 8 is positive 4. And positive 4 is a number that's greater than positive 3, so it worked. So what we're saying here is when you're solving for the set of numbers that works in the inequality, if you happen to be using multiplication and division of a negative number to isolate your variable, make sure you flip your sign, otherwise your set of numbers will be invalid. Let's just see what that means. Let's just try one here. Everyone try this one at home now. Let's see. Let's go with x minus 5 is less than 3. Let's solve that one real quick. So what I want you to do is solve it. Give me a set of 3 numbers that fall in that, a range of 3 numbers that could be possible values after you solve it, and graph your solution. Okay, this is a simple one. So here's what we're going to do. For this question, you're going to solve it. You're going to create a mini set of values using these cool little brackets here. You're going to graph it on a number line. And you're going to verify with substitution. So really, when we give this question, you should be able to do all 4 of those. So let's try it now. So if you're going to solve it, you're going to use your algebra sense to add 5 to both sides. You're going to create the answer of x is less than 8, or all values less than 8 will work. So solved. The solution is all values less than 8. Give me any value less than 8. We can start with 7. We can start with 6. We can start with 5, dot, 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 forever. That's a mini set of values. If I graph that, 8's in the middle, 9's over here, 7's over here. It does not include 8, so I use an open boundary, and all values less than 8 are the graphed solution. And if I verify with substitution, I take any number from my mini set, and if I substitute it into the original inequality, it should be true. So I'm going to choose just 7. So there's x minus 5 is less than 3. If I choose 7, 2 is less than 3. So I have verified my solution. Yes, when I substitute 7 for the x value, it does create a number, in this case 2, which is less than the number 3. If we take another example, let's just go with negative 2x is greater than or equal to 4. Okay, let's try and do that again. Let's try and solve. Let's create a mini set of numbers using those funky brackets. Graph it using a number line and substitute to ensure your value is indeed correct. So when we solve it, obviously what we're going to do is divide both sides by negative 2. But remember what we said before. If you multiply or divide both sides by a negative value, in this case we divided both sides by negative 2, you have to flip your sign. So we're going to go this way, and that will be our solution, right? So by flipping our sign, we end up with the solution of any number that's less than or equal to negative 2 will make this expression, oh, what happened there? We'll make this expression, any value less than or equal to negative 2 will make this expression greater than or equal to a positive 4. Okay. I don't know what happened there. It went berserk on me. Let's check it out. So there's our solution, any value less than or equal to negative 2. Create a mini set. What's any value less than or equal to negative 2? Well, obviously negative 2 would be our first number. Any number less than that would be negative 3 and negative 4 with a dot, dot, dot. There's our mini set of numbers. If I graph it, put negative 2 in the middle. Put negative 3 over here, put negative 1 over here. Open or close boundary point with this inequality. A closed boundary, because we can include the number negative 2. So we put a closed boundary point, and any number less than or equal to means my arrow goes this way. And finally, verify your solution. Negative 2x is greater than or equal to 4. Choose any of your numbers that are in that solution. I'm going to choose the number negative 2. Now I'm going to choose negative 3. So substitute negative 3 for your x value. And as negative 2 times negative 3 is a positive 6, is that one of the numbers that is greater than or equal to 4? Yes, it is, right? So in that particular instance, negative 3 works. If I did negative 2, I would get a full positive 4, and 4 is greater than or equal to 4. So then my set is valid, my graph is valid, I verified it with substitution, and I've solved the inequality.